Imagine your eyes are tired and you are asked to find the name of the substance kept before you. On touching the substance, you feel it is round in shape, little hard and smells like rubber. Now you can easily recognize it. It might be a ball. Every substance have unique properties. These properties can be classified as physical and chemical properties. Physical properties can be measured or observed without changing the identity or composition of the substance. On the other hand, chemical properties can be measured or observed during the occurrence of a chemical change. Some examples of physical properties are odor, color, melting point, boiling point, density, etc. Whereas composition, combustibility, toxicity, flammability are examples of chemical properties. For measuring the physical properties, the English system and the metric system are used. English system uses yard, feet, inches and fraction, and metric system uses millimeter, centimeter, decimeter and meter. Now, to begin with the SI system, it has 7 base units and they are length, mass, time, electric current, thermodynamic temperature, amount of substance and luminous intensity. The other physical quantities can be derived from these base quantities. Some of them are speed, volume, density, etc. The first unit we are going to discuss is length, whose SI unit is meter, which is represented as m. It is defined by taking the fixed numerical value of the speed of light in vacuum, which is equal to 299,792,458 meter per second, where second is expressed in terms of cesium frequency delta V to the base Cs. Next is mass with SI unit kilogram. It is defined by taking the fixed numerical value of the Planck constant H to be 6.62607015 into 10 to the power minus 34 when expressed in the unit joule second. On the other hand, the SI unit of time is second. It is defined by taking the fixed numerical value of the cesium frequency, the unperturbed ground state hyperfine transition frequency of the cesium-133 atom to be 91926317770 when expressed in unit hertz, which is equal to inverse of second. Next, in the case of electric current, the SI unit is ampere and is denoted by A. It is defined by taking the fixed numerical value of the elementary charge E to be 1.60217664 into 10 to the power of minus 34 coulomb. Moving forward to thermodynamic temperature with the SI unit Kelvin, it is defined by taking the fixed numerical value of the Boltzmann constant K to be 1.380649 into 10 to the power minus 23 joule per Kelvin or kilogram meter square per second square per Kelvin. On the other hand, for the amount of substance, the SI unit is mole. 1 mole contains exactly 6.022140076 into 10 to the power of 23 particles. As you can see here, this number is the fixed numerical value of the Avogadro constant when expressed in the unit mole inverse and is called the Avogadro number. Finally, we have luminous intensity. It is denoted as I to the base V. The SI unit is candela and it is defined by taking the fixed numerical value of the luminous efficacy of monochromatic radiation of frequency 540 into 10 to the power 12 Hz to be 683 when expressed in the unit 1 meter per watt, which is equal to watt per candela steradian. Some of them are deca, deci, centi, milli, micro, respective to the powers. For example, 10 to the power minus 21 is called zepto and its symbol is Z. Now, let us focus on most commonly used units. First, let us understand the difference between mass and weight. Mass of a substance is the amount of matter present in it. The mass of the substance is constant throughout. The weight is the force exerted by gravity on an object. The weight may vary from one place to another due to gravity. Next is volume, which is the amount of space occupied by the substance. The SI unit is cubic meter. A common unit, liter, which is not an SI unit, is used for measurement of volume of liquids. Here, 1 liter is equal to 1000 milliliter and 1000 cubic centimeter is equal to 1 decimeter cube. In case of density, it tells us how closely the particles are packed. Density of a substance is given by amount of mass per unit volume. The SI unit of density is kilogram per meter cube. Moving forward to temperature, there are 3 common scales used, which are degree Celsius, degree Fahrenheit and Kelvin scale. The SI unit of temperature is Kelvin. The thermometer with Celsius scale is calibrated from 0 degree, that is freezing point of water, to 100 degree, which is the boiling point of water. The thermometer with Fahrenheit scale is calibrated from 32 degree to 212 degree. We can note that the negative temperatures, that is below 0 degree, is possible in Celsius scale but not in Kelvin scale. The temperature on scales can be related to each other by the given equation. We have seen different measurement systems. Now, can you match the following prefixes with their multiples? Try it out. Now, let us summarize what we have learnt.
Manorama Horizon. Learning made simple.